Okay, so today I'm talking to Antonis Bartsiokas, who's an emeritus professor of physical anthropology and paleoanthropology at Emeritus University of Thrace.
Thrace.
Of Thrace, yeah, sorry. So the reason recently, some of you may have heard Antonis hit the headlines, so to speak, quite recently, and this is how I found him because of some conclusions and some suggestions put forward with another scholar, another scientist, Juan Luis Arsuaga, if that's how I pronounce it. The
Juan
idea.
Luis Arsuaga.
Okay, yeah, that's right. So the idea, which Antonis himself admits may sound like science fiction, although it's not, is that perhaps some of our ancestors, long time in the past, hibernated through some cold, perhaps cold months of winter. But so we'll talk about it. But firstly, Antonis, thank you for being here. I'm really excited to talk to you today.
Thank you for inviting me.
Yeah, I tried. I always try to introduce every speaker, but I try my best. But is there anything else? Could you perhaps, before we start talking about your research that I mentioned, which is absolutely fascinating and amazing, could you just tell me a little bit more what you do in general? Maybe what's your specialty, what you do on daily basis. So a little bit about yourself.
Well, I am a retired professor now, and um, I'm still interested in paleoanthropology, and I'm still doing some research on that. I collaborate with many people in Greece and abroad, and I this work on hibernation was the one that hit the headlines,
Mm-hmm.
and I'm happy to talk about it with you now. What else you want me to say?
I think before, because obviously the main, and I'm really looking forward to hear about this work. But before we move on to details, I was hoping to talk a little bit about hibernation in general. So how it works and how it works in animals and generally even to define what hibernation is, because I don't think I think that an average person tends to think that when you hibernate, you're asleep, and I don't think it's always the case, is it? So when we talk about hibernation in animals, do they actually sleep, or do they just slow down their metabolism and they enter this
Exactly,
state?
you're right. It's not just a sleep.
Mm-hmm.
When we sleep, our body temperature goes down, but it doesn't go down as low as in the hibernating animals.
Mm.
So let me give you the definition of hibernation,
Okay.
which is the basic thing. And hibernation is a physiologic adaptation to anticipated famine that involves a decrease in metabolic rate and body temperature in a niche of constant darkness.
Mm.
So, constant darkness is a key ingredient to hibernation
Okay.
because it causes physiological responses. Okay, it's not only cold and it's not only famine. Famine is also a key ingredient to hibernation because animals that hibernate do that because they have lack of food.
Mm.
There is no food to eat during winter. So that's one key ingredient. For instance, Arctic people who may live in the same temperatures they do not hibernate because they have food year round.
Mm.
So they hunt year round, so they have lots of food. And most of this food is fat from seals and cetaceans, that is whales or something. And this fat is full of vitamin D.
Mm.
So the fat in these animals is very crucial for the survival of the Arctic people. So because they have this year round, they do not need to hibernate.
Mm.
And also, I was talking about darkness. Darkness causes some physiological responses because uh, cortisol is secreted by the adrenal gland, and it causes to the temperature, the body temperature, to fall down, and it also causes um, um, resorption of bone, and also stops growth,
Okay.
stops bone growth. That is important because it explains what I saw in the histological sections of the Atapuerca people, which we studied with Professor Arsuaga, who is the excavator of these bones. So cortisol lowers the temperature as well. So it causes what we call hypothermia. And that's more or less what is happening during hibernation. This is the bake, and the metabolic rate falls. And um, yes, um, y- I can tell you about some references from the ancient sources if you want me.
Yeah, of course.
Well, there are first the father of history, Herodotus, talked about it, and he said that people north of Scythia, what is today Russia,
Uh-huh.
uh, fall asleep for half a year because they lack food, and this is more like sounds like hibernation. Another important case was uh, Epimenides. Epimenides was a guy who is reported to have lived for many decades, many years, 150 or more years,
Mm.
and he was reported to die and come to life every year. So this sounds like he was going into a cave every winter, coming out the
Mm.
next summer. So also this guy, uh, the principles of this guy were that darkness and moisture are are key for this world, for the origin of this world. So, and these are important in our case because to say that he must experience hibernation, otherwise he wouldn't say that, because as we said, constant darkness
Mm.
is key ingredient in caves and for hibernation, and also moisture. Why moisture?
Mm.
Moisture is important because in caves there is 100% moisture, and this moisture causes the absence of positive ions. So the atmosphere in the cave becomes very ionized. And because it becomes very ionized, this is very important for the health of the individual because it gives the vitality to the individual because it causes the secretion of serotonin. Serotonin is a hormone that it vitalizes the whole organism. So uh, is it is renowned the what we call today Epimenidian sleep, and the Epimenidian sleep is what we believe today to be hibernation. So there is evidence from the ancient world that people could fall in some sort of a hibernation. And this is even happening was happening until recently in northern Russia. People were falling in a state called Lotska. And this state is in which state the people were sleeping for half a year. So because they didn't have any food to eat. So there is evidence from the ancient and recent sources that even nowadays modern humans can have the ability to hibernate.
That's interesting.
And another thing is that even modern humans can fall into hibernation by technical means. So because AMP is monophosphoric adenosine, it's a molecule that gives energy. AMP is a key ingredient to hibernation. And they have done medical doctors have done experiments with humans, living humans, where they administer by injections AMP. And the people fall into hibernation. So they had all these characteristics of hibernation: low metabolic rate, low heart rate, low temperature, slow breathing. So they had these symptoms. So technically, it's even today modern humans can fall into hibernation by technical means.
Yeah, that's so many interesting things that you mentioned. I was going to address. So I'll just take turns. Firstly, it's so interesting that there are sources, ancient sources, like you mentioned, and I hope I'll talk to you more about this, that actually talk about hibernation and these people and this person who, every year would fall asleep. It's very interesting. Also, you did mention the drop in temperature, which is interesting and important. When animals hibernate, that there is this drop in temperature, because this is important, and I was going to talk to you about it when we talk about some criticism of this idea. But you mentioned, and this is important, that actually it's been possible to induce this state in modern humans, and I thought the same even about the temperature. I may be wrong, but I think that heart surgeries, for example, they require, of course it's not for months, it's only for a few hours, but they require they also doctors also induce or somehow cause the drop in temperature every time a heart surgery is performed. So it's not so the criticism saying that a person would die after the temperature drops to certain, I think 20 degrees Celsius. I think the criticism says that we would suffer from cardiac arrest, which, like I said, made me wonder, because it does not have to be the case. If we perform, for example, surgeries, I think that's what happens. And now you said that there's been experiments which also showed that it's possible. I think it's very important because we'll talk about some criticism later, and whether and we'll try to address that criticism of this idea.
Sure.
Also, I want to talk, and we will come back to it, some more about modern experiments and how we can, how hibernation may help people. This is another interesting topic that we will address. But firstly, we're before we move on to the details of your study, we talked about animals, and you mentioned that it's because of lack of food, which I think is also important in light of what we'll talk about later, because I think that initially the idea was that it has to be because of the cold exclusively, which later I think, which nowadays probably is not the main belief, is it? I know there are, and I was hoping to talk about it, some animals in countries where it's not even cold, so there is no real winter, and they still hibernate, right? So it's more about the lack of food than not necessarily about surviving the winter. Is that right?
Yes, a lack of food and possibly lack of predators.
Mm-hmm.
It's another hypothesis that has been put forward recently.
Mm-hmm.
So that's why it may have it is happening.
Yeah. Like I said, I read about animals in Madagascar who hibernate, and I think I'm not sure if that record belongs to an animal from Madagascar, but I think I read somewhere about animals, some kind of a mouse that hibernates for over 11 months. So that was my another question. How long, like, what's the record, or how long can a being, or an animal or a human or whatever hibernate for, and also what happens? We already established that this animal is not sleeping, but what is it doing? It may sound like a basic question, but what would happen if I entered a cave where this animal is hibernating? Would this animal be aware of my presence, or what exactly is that state? What's happening?
I'm afraid it won't be aware of your presence,
Mm-hmm.
but unless you disturb it. For instance, if you disturb the bears that are hibernating, they will wake up
Okay.
after a while, and they will be very dangerous.
Mm.
And you have to be careful. Prehistoric humans were hunting them and killing them when they were hibernating. So, but if you disturb them,
Mm-hmm.
they wake up, and they are very aggressive because they've got their cubs as well.
Mm.
Another important issue I'd like to address relating to your previous question is that hibernating animals gain time.
Uh-huh.
During hibernation, it's as if the time dilates.
Mm.
So instead of, for instance, spending 6 months in a cave, for them it's much less than 6 months. They have a different perception of time, which is much shorter. So they think that maybe 1 month that they hibernate. So this is because the metabolism goes down, and that's why the hibernating animals live much longer than the non-hibernating animals, which have the same size like them. For instance, the bats live 40-50 years, whereas the animals that have the same size with them live only a couple of years.
Interesting.
And also the uh, the 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 dormice live that hibernates lives much longer than the mice that lives for a dozen years, and the mice lives only very short time. So the hibernating animals live much longer. The longevity increases dramatically. And this reminds us what I told you about Epimenides.
Yeah, I was
Epimenides
going to say that. Yeah.
lived, lived for so many years. You know, he one time, once he was back to his house and he found his brother very old.
Mm.
So the ancient Greeks had understood somehow the physiology of hibernation, and they knew the effects it had on humans.
Yeah, I was just thinking when you mentioned that, and of course, we like to say that in stories there is always some truth, and this just made me remember even some other folklore stories. I will put it in on the screen because I can't remember this guy's name, but something Van Winkle or something. There was a story about a guy who also went to the mountains. In that story, he just fell asleep, like not in the cave, somewhere, and then he woke up, I think, years later, and came home to find his family dead and this kind of thing. So it's interesting, how much these may have been influenced by what you said, by some knowledge of this process. And I was also going to ask, I don't want to forget that before, because after that I just want to move into your research. I was going to ask about what you said about people in Russia, and how much evidence there is for that, and how do we know about these people?
There are ethnographic reports and publications about that,
Okay.
which I mention in my paper.
Mhm.
So there are references about that in the publications.
Okay.
That's how we know about that. And yes, that's it.
Yeah, I will make sure to also link to your paper and link to any interesting news articles as well, because you've been in the news recently. So I'll make sure to link to all of these, so so the viewers can explore these a little bit further. But yeah, so now I think it is time to move to your study. I was also going to mention that until recently, as far as I know, I'm not an expert, but I try to prepare a little bit. Until recently, it was not even known that primates can hibernate in general. So I think 2004 was when they discovered that they can. Again, it was in Madagascar. So this is again just shows you how little we know about this. So until recently we did not know that primates can hibernate. Until recently, it was felt that it's only about the cold winter. So this is just to bear in mind, because we'll talk about your findings and we'll talk a little bit about criticism, of course. So now I think it's time to move on to your findings, because that's fascinating. So generally, if I was to summarize, just tell me if I'm wrong. In a very plain language and very simple language, you basically found in caves in Spain, in modern current Spain, you found evidence in bones of ancient people, so to speak, evidence of some disease that may only be caused by non-tolerated hibernation in dark cave. That's the words from your article. So is that more or less what happened? But I would like you to, of course, explain more and more professionally than I did.
Yeah. Well, the thing is that hibernators accumulate fat during summer and sometime after summer in autumn. And they do that because this is the only thing they have to consume during hibernation, because they have nothing to eat. So there are of course cases where they store some food, some nuts and things, where during arousal they consume them. But basically what is important is the fat they accumulate in the body, and this is called the pre-hibernating fat. So this fat is very important because it doesn't only give energy, it also gives vitamins and water. And vitamins, the most important vitamin out of them is vitamin D. Vitamin D, we can say that it is an elixir of life, and it's very important for hibernators because the the parathyroid gland activates and starts to erode the bone. And vitamin D, because there is the calcium lowers, and there is need for the organism to have calcium, because this is how our heart works. Without calcium, it stops. And the parathyroid hormone erodes the bones and produces more calcium for the homeostasis of the blood. And um, this there is so there is the calcium lowers, and there is need for calcium. So this resorption of bone causes some effects which you can see under the microscope in the histological sections. And uh, this how hyperparathyroidism is diagnosed, which is the common disease between hibernators and renal osteodystrophy. So, um, how do we know there was a hyperparathyroidism in this particular case in Atapuerca? We do know that because it has resorbed the the trabeculae. The trabeculae are elongated rods of bone which make the spongy bone. And the inside this is this is a compact rod of bone. But in hyperparathyroidism, the bone is eroded within. So the trabeculae appear as if they are um, like they have a tunnel inside.
Uh-huh.
So this hole is what we found in this particular population. And I was looking under the microscope, and 20 minutes had passed until I found it, and I almost had a heart attack, because that was the crucial proof for proving my argument that there was hyperparathyroidism, because without it you cannot have hibernation. So that's how hyperparathyroidism was established. And the other diseases, another important disease is rickets. We have in this population we have renal rickets. Rickets is a lack of vitamin D basically, and um, rickets is a very important evidence for this population because rickets, we don't have rickets in any other population, in any other skeleton, in any other bone found in caves. This case is the only evidence that we have rickets. Everywhere else, in all the caves in the world, we have no bones, human bones, with evidence of rickets. Why is that? Because the people were going in and out of the cave every day. They didn't have to stay in the cave. So they didn't develop any rickets. Whereas here, the evidence of rickets, which is very easy to diagnose because is in the supraorbital area, and it's very conspicuous and very easy to diagnose from all other diseases. That was the first thing I saw. It is very striking for people who have for skulls who have this disease. Um, it's called rachitic hyperostosis. So the important thing is that this evidence of rickets gave me the idea that the people were staying for a long time there. You can't develop rickets just only staying in one night or a few days inside the cave. You have to be for months and months inside a cave or under constant darkness to form this disease in the orbital area, supraorbital area. So uh, then the idea of hibernation came to me, and I said, is it possible that may have hibernated? So that was a crazy idea, but I had to examine it. So I looked in the literature about animal hibernators, and I found the diseases that are formed during poorly tolerated hibernation. And one of the most important was, of course, hyperparathyroidism and also rickets. And then I looked in the medical literature to see modern humans, what are the bone evidence for these diseases, especially hyperparathyroidism, because to paleopathologists like me, rickets is very well-known pathology, and hyperparathyroidism has never been found in fossil humans. So I looked in the medical literature and I found all these lesions. And these lesions were exactly those lesions that we had in Sima de los Huesos in Atapuerca, which were inexplicable in the first place because you don't see these lesions everywhere else. So that's how we describe these lesions and identify these lesions and diagnosed with pathognomonic characters the diseases. So for the diseases in Atapuerca, there is plenty of pathognomonic evidence because we have thousands and thousands of bones, 7,500 so far, and every year the number is increasing because more and more are found. And these belong to at least 19 individuals. It is the richest paleoanthropological site in the world. So the so that it is character. That's why it is characterized by UNESCO as a cultural heritage site, and so we now the question is what else evidence we have to support hibernation apart from those histological lesions. The other evidence is um, there are during hibernation in Atapuerca there were uh, parts of bone that were deposited, and they were forming strata of bones that were formed, and between the strata we have some gaps, which means there was no deposition. So these were formed during hibernation, and these gaps also appear in hibernators. So these gaps are conclusive evidence of hibernation, because during hibernation, as I said, there is hypometabolism. The bone formation stops, and collagen is excreted, and these gaps were formed because growth stopped. Growth stopped, and the gaps were formed. So this is evidence of hibernation, and the same happens in other hibernating animals like bears, which the evidence of hibernation is diagnosed by the lines of arrested growth. Here we don't have only lines of arrested growth, but we have whole zones, empty zones of bone, from hibernation, which means that the stress during hibernation was even stronger than that in bears. Okay. So yeah.
Yeah, I just wondered. So there is this bone pattern, this structure that shows that there was this slow growth, as you said, in that state when metabolism slows down, and you mentioned that it's typical of that we've seen same kind of patterns in the bones of animals that hibernate, and I wondered, has it ever has anything like that been found in human bones, apart from this context where you believe it's, I mean, it sounds clear that it's, it points to hibernation because hibernating animals have the same, but has it ever happened in human bones, like in other contexts, or as a result of some disease, or this kind of these gaps that you described? Just wondering, trying to imagine what potential criticism could be. So I just wonder if this has been pointed out.
Yeah, the histological appearance of these features, of these lesions, it's unique to this population. We have no other human bones with this stratification of bone, which we have gaps and then bone and then gaps and then bone. So this is unique in human bones. No other human bone has this stratification in the histology.
Yeah. Okay. Yeah. This is interesting. This is why I asked, and I wondered. I just remembered a story from another article that I read, and I think again coming back to the criticism and those who say that we are not. I think it's a common assumption that human body is not fit for hibernation because of the temperature, what I mentioned before, what you mentioned before as well, because of the temperature drop, and that our hearts wouldn't work under such circumstances. But then I remembered, in addition to what you already said about these experiments where hibernation, the state has been induced. Also, I remember, I don't know if it has anything to do with it, but there was a story from Japan about a man who went missing on Mount Roko. He went missing basically, and he split up with his friends. He lost his way, slipped in a stream, and broke his pelvis. The next day, as the article says, I'm reading it now, on the second day the sun was out, I was in the field, so that's this man saying, and I felt very comfortable. That's my last memory. He fell asleep. He was found about 20 days later, and according to that article, the doctors believe, it was very cold, of course, the doctors believe that he lost consciousness, and his body's natural survival instincts kicked in, which sent him into a state similar to hibernation. So his temperature, so the temperature on the mountain dropped as low as 10 degrees Celsius. So basically his temperature dropped as well, and he survived over 20 days. I just wondered if it makes sense to you, and whether you have any thoughts about this, because it kind of shows that yes, perhaps we are capable of, even modern human is capable of hibernating, or at least of some similar, entering some similar state.
Yes, this example shows exactly the hibernating capabilities that modern humans have. In this accident and many other accidents like this have happened, and the guy survived for 3 weeks. But I have to point that for him it was not 3 weeks. It may have been 3 days, because the metabolism lowers, the time dilates, as I said, and the natural biorhythm slows down. So an important thing is that also there are receptors in the nostrils and in the face that when the face cold, they lower the temperature of the body. So they keep the body in a metabolic state that it doesn't consume much energy. So the body may not be able to do much, but is able to survive when the circumstances change. Another key ingredient in this case is the brown fat. The brown fat is in this area of ours, and is the key tissue for the hibernators, because when the hibernators arouse from hibernation, they spend lots of brown fat. So brown fat is very important for hibernators, and the fact that we do have brown fat still in our bodies, it means it is another evidence that at some point in the past we might have hibernated. And you may ask me, when is this past? And that's an interesting question, because I believe this past goes back 16 million years ago in Europe. What happened 16 million years ago in Europe? The animals and the apes were living in a very rich environment, lots of food, and they were very happy there. But 16 million years ago, the climate changed and severe cold came. So they had either to adapt or to disappear or to migrate to Africa. And some of them indeed migrated to Africa, and um, they they made the hominins from which we came from. So this is research made by Dr. Johnson and Dr. Andrews, and it shows that at that time some of the apes might have acquired capabilities for hibernation, because when the food was very scarce, the apes turned to carbohydrates, that is fresh fruits, and because with the uric acid gene, they were able to transform the sugar into fat, and because they were able to do that, they survived the harsh winters and the very cold climate. So when they went to migrated to Africa, they carried this gene, and so we have this written in our genes, this capability. So whether the capability is expressed or not, that's another matter, but it is written in our genes.
Yeah, this is all very interesting, and especially what you just said, that it's as we know, there are no, we don't have capabilities or organs or anything that is not needed. There is nothing in nature. There is nothing like that. So
Yes,
we don't.
exactly.
Mhm.
Exactly. You see, what is happening in our genome, uh, if something is formed, a capability is formed, and then it's not needed, the capability disappears, but it's still written in our genome. So from our genome, it doesn't disappear. It's still there. And so that the organism uses it when it's needed.
Yeah, and this kind of leads. It's very interesting. It's fascinating, and I will ask in a second about the future of this and what else what you are doing now and how do we investigate it further. But just made me think what you said firstly about us needing that having this capability, and also what you pointed out several times, namely that for the hibernator the time almost kind of well, not slow down, it's actually the opposite, speeds up, meaning that we don't experience the time the same way. The reason I find it interesting is that there currently there is research into hibernation that's been done in the context of space travel, and as many people would have seen from movies where the astronauts are sent into space and they enter some kind of a state similar to hibernation. There's actually research and researchers who kind of explore this idea, and so what you said, again, it's something we know from science fiction movies where an astronaut enters that state, and then for him or her, it's he or she wakes up. It feels like 2 weeks, but it's been a year or whatever. So I was really excited to read about this, and that it's actually something we're thinking about. And then considering what you said about the experiments nowadays, where we're trying to induce this state. So is that something that would you say that this could be one of implications, or almost a natural progression. So our ancestors started it in completely different circumstances, but now our evolution and our expansion into space, in all of that, we would actually rediscover that capability of ours, and make and put it to use again. Does it make sense, or is that too much of a sci-fi fantasy idea, do you think?
No, I don't think. I don't think it's too much. I think that in the future we'll be able to hibernate in the spaceships. Not this way it's portrayed in the films, but
Mm-hmm.
we'll do be able. I believe we'll do be able to hibernate. The problem is that if we do not hibernate after a year in space, because the two strands of the DNA open and close, the cosmic radiation causes lots of faults in these strands. So these mistakes in the DNA, in the sequence of the bases in the DNA, is harmful and causes cancer.
Mm-hmm.
So that's why you have to get the people from the space, the astronauts. We have to get them back after a year. But if they manage to hibernate, the two strands of DNA remain close together. So the cosmic radiation won't be able to cause so much damage, and so the people will be able to survive without carcin for longer periods. So I believe in the first place, for a couple of years, we will be able to do that so people can reach Mars and come back. We need 2 years to go and 2 years to come back. So I think this is feasible in the next decades, so that the people are not in danger of having cancer with these long trips.
This is
And
fascinating. Sorry, I was wondering because I heard about this idea, and I heard that hibernation would protect us from radiation. So it's very interesting that you actually explained this, because I was really wondering, like, why would it protect us from radiation? But you just explained this, and this is very interesting. And I also thought about the other thing, namely, would it not affect us? Our muscles, if we were in that state, and the same applies to animals. That's what I wanted to ask. How is it possible that after some certain period in that state, their muscles and their bodies function as before, as opposed, for example, to a person who spends a lot of time in a hospital, and then they have to undergo certain treatment and exercise in order to start walking again. How is that not the problem with hibernation?
well, in the case of the Sima people from Atapuerca, we have very strong muscle attachments on the bones. So it seems that they were not affected by the hibernation. So if we discover the mechanism of hibernation in detail, and in my paper I produced this mechanism, the basics of this mechanism, and we will be able to to manage also for the muscles not to be affected.
Mm.
And I think when we study hibernation in detail and every hormone that is involved, we will be able to make hibernation viable without effects from these diseases. For instance, we can inject vitamin D in the body during hibernation and these long trips so that there is no lack of vitamin D during hibernation, and also other important hormones or AMP, as we said, or something like that. I think with lots of experiments, people will manage to find what exactly is needed for
Mm.
spaceship traveling and hibernation and these spaceships.
Okay, just one last question about your findings. I forgot to ask. Is there? Do you have an idea, or perhaps is there evidence, or for how long? How long do you think they hibernated for? So the people, that you investigated, is there a way to establish, or a guess?
Yes, my guess is the 4 months, but it could be 8 months. We because there are some gaps as well, that minute gaps that give us this idea. So that's what I think, and we have to do a lot of work to find more details about that.
Hmm.
Yes, I guess it's either 4 or 8 months the Sima people were hibernating.
Uh,
Oh,
s- so are you still involved in? So just to kind of wrap it up and finish, do you is what is currently being done to further explore these ideas? Are you still involved in exploring this further? Are there any are there any maybe additional new people or universities that joined in? What are we doing? Because of course, I mean, all of this sounds so interesting and so possible. So it's not by no means is it science fiction or fairy tales. It's scientific, plenty of scientific evidence from what you described, and something that completely changed the way we think about our own capabilities and our ancestors' capabilities. So I'm just wondering what's being done currently at the moment. What's being done to further explore these ideas and these mechanisms and everything we've been talking about.
there are lots of medics and biologists that do research on hibernation and try to find out the mechanism of hibernation so that we use this knowledge for transplanting various organs or for various diseases, for diabetes and also obesity. This research may help all these diseases and a lot more diseases which I don't have this in my mind right now.
Mm-hmm.
But and so the people who there are lots of people who doing research on hibernation nowadays, and from our part, we're doing research to establish the mechanism of hibernation in the Sima people from Atapuerca, and lots of PhDs are needed to study this phenomenon in the Sima people from Atapuerca. So we're working with Professor Arsuaga um, for this sort of research.
Mm. Okay, yeah, that's interesting. Lots of PhDs needed. So hopefully this this conversation inspires some people to think about exploring these ideas further. So future generations. And for now, I think is time. So thank you again for this interview.
Thank you very
I
much.
Yeah, it was great to talk to you, and I will definitely follow your work, and it's all so interesting. And like I said, I'm hoping that perhaps in the future we will meet again and discuss, some new developments.
Yes, sure.
Hmm.
You
Okay,
are
yeah,
welcome. You are welcome anytime. Thank you very much indeed.
yeah. Thank you.